So I want to give you a little bit of stuff about proofs and two-column proofs. We did a little bit of this when we first lost our schooling for COVID-19, but we didn't really go into detail. And I want to connect the two-column proofs to what we did earlier in the year with the flowchart proofs. They're the same thing. It's just a different way to show your information, to organize your thoughts, okay? To be honest, most of the mathematical world uses the two-column proof method for geometry proofs. I think the flowcharts are sort of a new thing, and I like them as a way to introduce the thinking process as opposed to the two-column chart, which looks like a bunch of steps, and it doesn't really work that way. So let's take a proof that we can do very easily and change it from flowchart to two-column. And I'm going to show you how to do two-column proofs on Delta Math as well. So we're going to take this proof. This is a proof straight from Delta Math, okay? And I'm going to do this as a two-column. I haven't done this proof yet, so it's possible I'll make mistakes, and we'll go back and fix those. So for once, you're getting to see me do a proof right from scratch, no planning whatsoever. So let's get this proof going. We always know we start with our given. So with the two-column proof, my given is E as a midpoint. I'm going to abbreviate of BD. Now I'm going to write that as my first part of my given. And remember, that is a statement that I'm making about the proof. Okay, so E is the midpoint of BD, that is given. Now from here, before I do anything else, I like to go, what does that tell me? Well, since E is a midpoint of BD, I know that BE is congruent to ED. And my reason behind that is because a midpoint makes two congruent segments. Basically, it's the definition of a midpoint. Okay, so I can mark that into my picture, BE and ED. There we go. All right. Now that gives me one set of congruencies. So now I go back to my given for more. AC perpendicular to BD. That also was given to me. What do I know about that? What does that tell me? Well, that tells me perpendicular lines give me right angles. So I get a couple right angles. Now, before I name my right angles, let me look at something. Let me look at what triangles I'm working with. BAE is one triangle, and DAE is another triangle. The reason I want to look ahead here is I want to make sure I name my correct right angles. So BEA is a right angle, and DEA is a right angle. And I know that because now my theorem from your theorem list, perpendicular lines form right angles. And what do we know about right angles? Well, since I know those are right angles, I know that these two right angles must be congruent. And again, what goes underneath is straight from my theorem list. All right angles are congruent. So I'm going to go ahead and mark that in my picture. I got a right angle and a right angle. Boom, good to go. All right, so now I need one more piece of information. I've got a side, I've got an angle. I need another piece. Well, I know that both triangles are using side AE. So I've used up all my given, so now I come up with something on my own. AE is congruent to AE by the reflexive property. Okay, so now I've got another side. At this point, I now have two sides and an angle between them. So that brings me, I have a side, an angle, and another side. So whoops, nope, that doesn't go there. Statements go here, not reasons. The statement is triangle BAE is congruent to triangle DAE. Whoops, E, can't spell. And my reason behind that is side, angle, side. And now we finished our proof. So this is something that we did earlier in the year. Now let's take this and translate it into a 2-column proof. And we're going to do this via Delta Math. Okay, so I've got the same proof up on Delta Math now. I'm going to flip my computer over so I have my keyboard accessible now. And notice that they already start out in Delta Math with your given. So E is the midpoint of BD. What does that tell us? Well, that tells me that I have some congruent segments. So I go here to my type of statement. I see congruent segments. So I click on that. I have to name those segments. So if E is the midpoint of BD, then BE is congruent to ED. Why do I know that? So remember we said that a midpoint creates 2 congruent segments. So I go through here, not a segment bisector, midpoint. There we go. And I go, is that right? I hit try. Okay, it accepted that. Notice what else it did. It marked it. It marked my congruencies for me. So this does a lot for you. Perpendicular. Okay, so type of statement. Let's make a mistake. I know therefore that angle AEB is congruent to AED because, let's see, all right angles are congruent. And I'm going to try that. It gives me a mistake. At least the angles you mentioned, you haven't proven it's a right angle. So if you make a mistake, it's going to tell you, hey, go back and take a look at this. So let's go back and go, okay, so cancel this information out. Let's now say, classify my right angle. So angle BEA is a right angle. Select my reason. Perpendicular lines form right angles. Now that's only one of the right angles. I hit try, it puts a little right angle mark. Now I got to get the other one, right? Another right angle. Now when we were writing this out, we could do this in one step, but we can't do it in one step here. Again, perpendicular lines form right angles, give them my try. Now I've got my 2 right angles. Even though it's marked them the same here, we still haven't said they're congruent. So now I want to say those angles are congruent. So BEA, takes a little time to write it in, so don't get too fast. AED are congruent angles because all right angles are congruent. I'll try that one. There we go. Notice what it did there. It marked them as congruent when I pressed that one. In fact, if I hover and point at this, you can see it marks it congruent now. There, it just marked one right angle. Notice that the one is shaded in. The other one is shaded in. So as you do this, you can point at these and it sort of lights things up for you so you can see what's going on. All right, I still need one more thing. And now I've used up all my given, right? So now I come up with something on my own, a congruent statement. I said that 2 segments are congruent. AE was congruent to AE. And my reason behind that was my reflexive property. Let me try that one. There we go. Now I'm getting where I want to be. Now I can say my triangles are congruent. So triangle AEB and AED. Notice how it marked that other side. It marked it with an X. That's a good way to show congruent that you mark the same thing twice. That's a neat little way. I may start using that. And my reason here, we said it was side angle side. Try it. They like it. Everything looks good. And now I submit my answer. Are you sure? Yes, I am. And there we go. Okay. So that's what we're going to do. We're going to spend the rest of this week working on these proofs. This is one assignment, is doing these, and this time it's without CPC/TC, just to get you used to this. Also, I'm going to have you do some that are just filling in the reasons. So I'll give you all the statements and you give the reasons, okay? So that's tonight's work, getting used to that. As we go on each day, I'm going to increase the level of proofs. So our next level will be doing more triangle proofs with CPC/TC, with other things, more complicated proofs. The next thing we'll do is look at quadrilaterals and using those things to do proofs. Okay? All right, that's our week's worth work, and this will finish up our geometry. By next week, we'll be done. So Friday will be your last assignment that you will have to work with. Okay. And we'll come back next week and talk about what's going on with that. Okay. Hope this helps you out. Hope you get a good practice with proofs. See you later.